We are going to go now into GitOps, CI/CD, and MLOps with Ritesh Shah.
Okay, so I hope you are all awake now to get through the GitOps journey. How many of you have heard about GitOps as a term? Okay, few of you? Okay. Okay, cool. And how many of you are actually doing development? Most of you, great, yeah. You guys will be more concerned about the inner loop than the outer loop, right? But you have to be concerned about the outer loop as well. I will explain you why, right? So, the topic we are going to talk about is GitOps, CI/CD, and MLOps. How many of you are actually working on machine learning here? Anyone? Oh, quite a few, great. Okay, cool. And how many of you are data scientists? Okay, so we have some data scientists as well here. Okay, so you got some understanding of inner loop, outer loop. I'll try and do a bit more clarification about that as well. We are going to use Jupyter Hub here. Anyone heard of VS Code, right? How many of you work on VS Code? I think that was the question never asked. Everyone, right? Okay. And Jupyter Hub? Okay, most of the machine learning guys, right? Okay. Sorry? Jupyter Lab, okay. So here we are going to use Jupyter Hub, which is like a software which we use and which gives you the same functionality as Jupyter Lab. Right? So we'll see that as well. Now GitOps, okay. So we'll see how it all comes together in this presentation. I am Ritesh Shah. I am a principal architect, part of the portfolio technology team working on cloud technologies and based out of Mumbai. That's my email ID if anyone wants to get in touch with me. I don't have Twitter handle. I only have LinkedIn account, that's it from the social network point of view. So this is the only touch point for me. Okay, so this is what we are going to cover here. I think I have some more time left. So we'll go to a demonstration as well at the end. I will demonstrate how everything comes together from the GitOps point of view. So we'll do what is GitOps framework, related developer tools. There will be too much for you to absorb, but I have provided links in the presentation. So you can go back and kind of like download and go through all those links on your own. This I think there is a recording as well. We can go through the recording as well. We'll talk about Open Data Hub. So Red Hat, I think we are having a managed services on Red Hat OpenShift Data Science based on Open Data Hub. Anyone working on the Open Data Hub upstream? No, okay, cool. So that's a new thing which you'll learn here then. And then we'll talk about the use case, object detection. It's a very naive use case, like not fully developed, but you get an idea in terms of how the overall framework works in for the machine learning operations. So we'll do a retail coupon application, and then we'll do a demonstration around that as well, right? Okay, so let's dive into overview. So what is GitOps frameworks? It's basically like earlier developers used to have a fantastic process in terms of collaboration, then security, overall CI, continuous integration, and how everything comes together, right, in terms of the delivery part of the application. So the same thing is getting into the infra space as well, where infrastructure as a code comes into perspective here, and you put everything onto your Git repository or a single source of truth. So it may not be Git, it can be any other SVM or any other source code repository which you can use. And you push your code there, which kind of like changes your application deployment or infrastructure or anything which you want to do it in production. You just push it through your source code. You don't actually go and do anything in your production environment, right? So that's the whole idea about how GitOps works. Now if you see, there's a formula here, infrastructure as a code, then do a merge request, and then the continuous integration and continuous deployment, right? So that whole thing put together gives you GitOps DevOps framework, which kind of like works for the MLOps as well. So more or less it's similar. I think only way the models are being contained and then published, right? That's something which we'll see here as well in this. So there's a single source of truth. That's what we always want here. For you to truly implement GitOps, you need to have multiple repositories. Like one is your manifest which you have, right, in your cluster. You need to have a repository for a manifest, then you need to have a machine learning source code repository, and then you need to also have an image repository, right? Like Nexus or JFrog, Artifact, or anything. So we use GitHub here as the source of truth. We can use anything like. And from the image registry point of view, we have OpenShift internal registry, right? So we use that for this particular example, but you can use any registry which is outside of your, sitting outside of your OpenShift container platform, and kind of like talk to that particular repository through your cluster. So there are some, so if you see CI and CD, right, we split continuous integration, continuous deployment. The image you see here, we kind of like fetch the model. I'm just talking from the machine learning point of view, but you can also think from the normal application point of view as well here, in terms of the way the pipeline works. So you fetch the model, you then basically do a sanity check on that particular model, whether it is actually, for example, in our app, if I'm going more than very high discount, right, my model is actually doing very high discount, then it's a business loss for me, right? So I need to have a check there so that if the discount goes very high, then I kind of like stop that whole pipeline and that code doesn't get into production, right? Build model, then I set the image into my, and then update the development environment. Once the development environment I'm comfortable, I will then initiate either a merge request or a PR, okay, where I say, okay, now you go and update the production, right? Then someone will actually go review, everything is fine in dev, and then kind of like submit, approve the request, that kind of like goes and gets your image hit into production environment, right? If it's serverless, you can split the load, you can split the traffic between older and the newer version. Purely depends on how you want to architect your rollout into production. Okay, so this is the CI part, continuous integration part I mentioned. Then once this does, and it finishes the dev part, then comes the continuous deployment, right? Once the PR is approved, the image has to be continuously deployed in your production environment, right? So how does that work? That works through a tool called ArgoCD. Anyone heard of ArgoCD before? No, right? Okay. So I have provided links to all the information here. So there is a ArgoCD link. Then the CI part which we do, right? How many of you have worked on Jenkins? Yeah, quite a few, right? And Tekton? Started? Not started? Planning to start? No? Okay. So, I mean, Tekton is a, if you want to truly leverage the GitOps power, right? Tekton is a way to go forward. Especially with the kind of, if you see the upstream, anyone worked on Jenkins upstream, by the way? No, right? So a lot of development have kind of like shifted to Tekton in terms of adding new features into it. Like Jenkins, if you have to actually update a task or create something inside in terms of this pipeline stage, right? You have to start everything from the first task, let it finish till the last, right? So a lot of developers' time is actually stuck just waiting to figure out whether it will clear or not, right? Complete the process or not as part of the integration. Whereas Tekton, you can actually test each and every step, each and every task separately. And once you are comfortable with all the tasks, you kind of like merge it into a single pipeline and then execute that. Okay, so that's the power of Tekton. And of course, it's again a declarative, like Kubernetes, we all know, right? It's a declarative platform, right? Everything you do in Kubernetes is declarative. You write in YAML, you can execute in YAML, you can get an output in YAML, push it back into YAML, right? So it's all about YAMLification. And Tekton, again, we use YAML. It's a declarative. ArgoCD is declarative. GitOps is declarative, right? So everything kind of like gets into the GitOps perspective and truly gives you a transformation journey into GitOps if you want to get your environment or your customers' environments to be adapted to the GitOps framework. So here, ArgoCD deploys the application. We define the infrastructure and application through ArgoCD. We can manage the deployed application through ArgoCD. So ArgoCD doesn't just push the image into production, right? So you have a set of manifest that this is my desired state in production, and you have it implemented by ArgoCD. What ArgoCD does is actually it has a reconcile loop, so it will go and continuously monitor. Sorry, I'm not able to see a few of the guys in the back because of the light. So it's kind of like a little irritating, but I mean, I'll have to manage it. So yeah, ArgoCD also continuously does monitoring of what is deployed in your production. So let's say if you delete your pod itself or your application, ArgoCD knows that that has to be there. So it will immediately sync it back, or depending on what time frame you have. So it continuously monitors and ensures that whatever is your desired state will always be there as the current state in your cluster. So that's the power of ArgoCD for you. Okay, ArgoCD manages, it keeps monitoring the deployed part, that's taken care of. Then you have Tekton, which is the continuous integration, which builds the container image for your model in this case, or for image for your application if you are using any other application. So you saw, right, through OpenShift console, you can actually create, you can just get the Git repo, point the Git repo, and it will, and build image, it will automatically detect, right, what image you need to build. Then there is a button where you actually also can say create a pipeline. So it will actually do a clone, build, and push pipeline for you automatically on the fly in the console. Right. And so here what we are doing is we are deploying it in development environment. So the CI part only works, the developer touches only the dev part here, okay, in terms of the environment as well. The prod part is not touched by the developer or the development environment at all, okay. Then it gets pushed into another repository, someone approves it, and then the ArgoCD kicks in, that it will go and actually do a deployment on your production. So you are kind of like creating all these things separately. Very secure environment, very secure from the overall DevSecOps ops story point of view, right? So that again is a good point to think of. Right. And the other thing we are going to leverage here is OpenShift Data Science. If you go to Red Hat's managed services offering, console.redhat.com, I think, you get to see, you actually can create a Jupyter, you get a Jupyter notebook there as part of the data science offering. Or you can actually get any other, like OpenVINO for Intel, if anyone is working on Intel or NVIDIA as well, right? We have NVIDIA operator as well now in OpenShift. So you can actually leverage GPU power as well when you're actually doing your machine learning product development, the application development, right? So yeah, so Open Data Hub is basically, it provides a set of tools, the AI tools for running large and distributed AI workloads on your OCP platform. So there is Jupyter Notebook. It's like the where you actually go do your development and also execute and test it out. I kind of like the Jupyter Hub notebook because you can write the comments, and then you can kind of like have a very seamless way of writing comments, execution unit, then the output is there, then go to the next stage, right? From the developer's point of view, right? So everything is well documented, right? And yeah, so I like the way it's structured. When you install, let's say, OpenVINO operator and then have that particular Jupyter Hub based on OpenVINO, you will find a lot of examples which are already pre-built into that particular environment. So you can just have open your notebook with a specific example and quickly get into what you want to develop from the machine learning point of view. So yeah, data science pipeline, there is model mesh serving. Yeah, I think most of the things are integrated into our data science. Exactly, I'm not sure when is it going to be GA'd or whether it's GA'd. So I need to check that. The Red Hat OpenShift Data Science. But that is based on this upstream Open Data Hub. So if you are really into data science or machine learning, this is something which you should definitely explore in your environment going forward. Okay, so there's a link to OpenDataHub.io as well. And of course, this is true for most of the applications. Like you have this red piece, which is an application, right? And it may be an intelligent application or it may be some other application. But that's a small piece, right? In the whole gamut of things which makes a true enterprise run its business, right? So what you have here, right? You have configurations, data collection, then there's feature extraction, right? There's a plan to have feature extraction bank also, right? And then you can leverage that feature extraction to pull and then get incorporated into your machine learning code as well. So that's a new thing. Even I need to check that what exactly happens to that. Your data verification, then there's machine resource management, analysis, process management, serving infrastructure monitoring, right? So many things to get your model running, right, for your business requirements. So this was adapted from Scully way back, I think in 2015. Right, and this is what an app does. This is a hypothetical app, right? So you go to a retail shop, you kind of like scan your mobile to get your, understand what is the discount on that specific product, right? So let's say you pick up a shirt, you take a picture of that, the model will kind of like detect that it's a shirt and then give you a discount coupon on that, right? And then you go and just finish your payment. So that's what we are talking about here, in this particular use case. There's a link to the repository of this particular application. So we'll walk through a few of these things depending on how much time we have, right? And what questions you have. So how the app is deployed in the OpenShift? Yeah, this talks about how it's implemented, right? Is it visible back there? Okay. Yeah, so we have the single source of truth here, the GitHub, right? In our environment, we kind of like a cloned using the GitHub is actually cloned in our environment. We call it Gitty. It's a small operator which my colleague has written to kind of like have the replica of GitHub into Gitty. So my cluster environment will have my own repository cloned with whatever I want to use. That kind of like goes, and then I have my application editor here. It can be either VS Code or Jupyter Hub or any other IDE you want to use, right? So the developer will go and update the Jupyter Hub. It kind of goes and push there in the Gitty. Now there is a GitOps, ArgoCD, which kind of like checks, okay, there is a change in my Gitty. So I need to reconcile now. So it will do analyze, observe, act. It will check whether the production matches with my Gitty source code. If it is so, it will continue just checking. Else it will actually go and update it, right? Depending on what logic you have set. So for ArgoCD, it will only check whether whatever is there in the repository is there or not, right? In terms of my production and dev environment, depending on how you have configured your ArgoCD for the continuous deployment part. And then here in this environment, I have OpenShift configured here, right? OpenShift pipeline, that's the Tekton part. And ArgoCD, we call it OpenShift GitOps from the OpenShift point of view, right? So the OpenShift pipeline does the CI part, which you saw earlier as well. There's a small pipeline listed here as well below. So the OpenShift basically, so once you update the Gitty, there is and update your source code, the OpenShift pipeline gets triggered. Okay, there's a trigger set in GitHub or in Gitty. The OpenShift pipeline will get executed. Once it finishes the execution, everything is fine, right? It kind of like goes back and updates your manifest repository, which tells that, okay, I have a new updated image tag now, okay? And once that new image tag is available, again the OpenShift GitOps ArgoCD will say, oh, I have a new tag now, okay, in my repository. So there is a change. Does it match my production? No, it will go and actually update that. So that's how ArgoCD will work and do a reconciliation. So it actually has a reconciliation tool. Following me on this? Any questions so far?
Yeah, like I understood, right, like first CI has to happen from GitHub to, right, like these pipelines, everything, integration will happen.
Yeah.
Then it will go back to GitHub and like ArgoCD will trigger, right? Then once it has to deploy, right, like wanted to understand this analyze, objective and act to this pipeline and how it's connected to this.
Yeah, so you have image in the image repository, right? Okay. So you are mapping in ArgoCD in such a way that you say, okay, if I have a new tag. So what I do is, this image will have a old tag in production, right? So I will say, okay, I had 1.0, the new tag, I will get a new tag name 1.1 in my Git repository. So ArgoCD will say, oh, I had 1.0 here, but I wanted to have 1.1, right? So it will say that there is a difference and it should go and update that.
Yeah, right, like one more use case, right? If I want to manage different versions, right, like how it supports.
Different versions of what?
Versions of an app.
Of app? Yeah, you can do that having different applications, different So one is you can do serverless, where you can have different version, and here you can have different namespace for different version as well. Right? It works with any, these are all open source tools working on Kubernetes. Yeah. Oh yeah, OpenShift is again a Kubernetes platform, right? Yeah, I would love you to actually use OpenShift, but no, not at all.
No, actually, you were talking about Tectons, right? I use Jenkins. So in Jenkins, all the pipelines are actually centralized steply, but Tectons are not centralized steply. It is like direct overflow of the pipeline. So what advantage? I didn't understand the advantage of Tectons over Jenkins because I personally prefer Jenkins.
Yeah, everyone will prefer the old way till you get the benefits of the new way, right?
No, I didn't understand the benefit because in Jenkins we can do it steply because we can see the pipeline running through the
Right.
process and see the stepped centralization. But in Tekton there is no
So
centralized.
if you want to implement the pipeline, I can put this whole pipeline into my GitOps.
Okay.
But Jenkins, you cannot put the whole Jenkins into GitOps. So if I want to deploy pipeline and the pipeline specific, so this whole pipeline, right, I can create through GitOps. And I can manage through GitOps, through
But,
ArgoCD.
for that only we are using CLIs, right?
So if you use Jenkins, you will not get the true GitOps way of pushing even your pipeline specific code into your Git repository, and then the whole thing gets triggered for you.
Okay, just one more question.
Yeah.
So I use Jenkins regularly for production and everything.
So I don't say Jenkins is
No,
bad,
no, no,
right?
I
It
know.
is a fantastic tool.
No, no, I know it is fantastic. I'm using it because Tectons is a new topic for me. I just recently came through it and I just researched about it. But I was not so satisfied because I have some compiling errors with it because we can't migrate suddenly from Jenkins, right?
Yeah.
So for me, the pipelines are the issues. So in Jenkins, we can alter the pipelines flow. But in Tekton, can we do that?
Yeah, you can alter the pipeline.
We can do that? Yeah. Okay.
But you want to have a sub pipeline, you can have sub pipelines also in. Then you can alter the flow.
Okay.
Through sub pipelines, you'll have to do it.
Okay.
Right now, the logic is not there to alter. So you have to do a sub pipeline, then do a when clause, and then alter it.
Okay. Thank you.
So if you want to actually see how this whole thing comes in, right? There is a retail dev GitOps link here that gives you the source code for the ArgoCD and the pipelines, how it's done, right? So you can go to that, that's my repository. And yeah, there is, I think, one repository, this one, in terms of how the application source code is. If anyone is interested to see that, right? So this is kind of like my application. Yeah, okay. So everyone can see me right here. So if I select this, it detects that I'm wearing a shirt, right? Yeah. T-shirt, right? It gives me a 14%, it's for my t-shirt, right? The off is for my t-shirt, 14%, right? Okay. So this is the application. Everyone got what exactly we are talking about in terms of the application use case here? So you're walking in a retail shop, you get to know, okay, you can identify an object, understand what the discount you get, and that's it, right? Sorry? Yeah, okay, right. So now getting into technicalities. So when on the OpenShift container platform, you can install, when you go to the cloud services of Red Hat, managed services offering, we have Red Hat OpenShift Data Science. When you go there, you will actually get this. There are notebook images. So you have the standard data science image, which has Python version 3.8. There is a CUDA image, which you have. There's a PyTorch, there's a TensorFlow. And then there are a lot of partners who actually provide their images, right? Like OpenVINO from Intel, or even from NVIDIA. So those are the images which you can use here. It will show up here as part of your notebook. So you select that. You select what your container size you want here. So you can select what kind of size you want, like 2 CPU, 6, depending on what kind of development you are doing, right? So you just select that and kind of like start the environment, okay? So this will be using minimal Python, right? So let this continue and we'll go to the next step here. So once it's up, right, I have used a standard image here. So, and then I had cloned my Git repo here, okay? Whatever the Git repo I had from the source code point of view, which I showed earlier. So that's kind of like cloned here, now. Right, so this is my main program here. So I'm using a CSV file. So let's see, what do we have in that discount data set, right? Right, so this is a CSV file I'm using out there in the model. So I changed this to, let's say, Wednesday, right? So as a developer, I'm working on this, right, in this Jupyter Hub notebook here. I go through and run step by step here, including documentation, right? Then here, basically, I'm actually creating my PKL files here using dump, and then I will basically use them as models. I dump it in a folder here. So once I do this, and let's say I restart my kernel and run all cells, so this will kind of like run the whole program here, the complete thing. It will generate the models, and then if I go to this folder, right, so I have these things generated seconds ago now compared to what was earlier. So I have the new model available, and like this is the inner loop we are talking about right now. Everyone got what is inner loop now? Yeah. Now once we push this, right? So I have this git here. I will just run this and then restart the kernel. So the moment I push this, it should go and kind of like update the Git repository, which has a trigger set in to trigger my pipeline here, like this. Okay. So what this is doing is actually building my model into an image, like just layering, using a UBI and then layering the model, right? And then straight away you get this in dev. Once you have this in dev, then the ArgoCD kicks in saying, oh, there is a change in the tag. I will go and update my prod, right? So that's how the whole thing works. So what are the stages here? Let's see a little bit about the pipeline here. Okay, so let me show you the stages first. Yeah, so these are kind of like stages here. So I fetch my model, generate tag, then there is a sanity check which I do. Then I build my model. I do a tag image, I do a set image in dev. Then I update my customize repo for the development environment saying that there is a new image. So it will actually go and update my, deploy it in dev. Then I will update the customize repo in the production. Don't worry about customize, I'll explain you in a minute what is customize. Yeah? There's one more tool we have to talk about. So this will go and update the repo, customize repo for my production. And then the ArgoCD will say, oh, there is a change, I need to go and push the new image into production. So it kind of like says it's triggered by, it says it's actually triggered by, there is an event listener in my pipeline which kind of like is listening to the trigger. So whenever there is an update to the Gitty, there is a trigger which gets to my pipeline on this particular listening. Right, okay. Then these are the tasks, so I can do individual tasks and test it out. There's this trigger which I have here in my pipeline. So this is all about pipeline. Now earlier you saw you were as a developer like updated the your model, right, using Jupyter Hub. And then this as an admin you can actually go and check, even as a developer you get a read access to check how is your pipeline progressing. If there's an error, you can go and fix it in your Jupyter Hub and push the code again, right? Till that time anyway, there's nothing going on in production, right, for you. This is all your development environment, your continuous integration happening, right? Nothing going into prod. Right. So now it's building model, it will do a Maven build here. So it will download the whole internet before it kind of like builds. That's how Maven works, right? Right, okay, so this is about the pipeline. Let this keep running. I have these workloads, there are pods here running, right? Now I have this kitty here, so this is my repository, which kind of like clone into my local repository here. So this is the repository I was talking about here. We have this base. Okay, customize, right, before that. So anyone heard about Helm charts? Okay, a lot of you. How about customize? Oh, a few of you, okay. So, I mean, Helm is where we actually do packaging of all your application manifest, right? I mean, we say application package, but ideally it's all manifest in Kubernetes environment, right? So we kind of like package together and use Helm. So we have our Helm charts, we have our values which we need to push into along with the Helm chart, and then we deploy it on the environment where we want to deploy the application. So another way is customize. So let's say you have this dev, test, prod environment, right? And then you will have multiple of your departments in your organization. So you'll have your HR department, your some data science department will be there, IT department will be there, right? So all these departments will, maybe they want to actually share the same source code in terms of the manifest and all, but do slight modification for their own requirement, right? So for example, a dev environment will be like, you just need 2 CPUs, but your prod you may actually need like, let's say 10 or 12 CPUs, right? So those minor changes, but using the same manifest, we can use customize to actually do that thing as well. So here I have my base image. So I have my base manifest here. So this has, so it actually has the source code where I can go and create my pipeline as well. So don't worry about this. So basically I am having this task as fetch model repo. So you see the first pipeline task or step which you saw earlier, right? So that was fetching the repository. So that's the first task I have. So it says cluster task, which means that it's already part of the OpenShift cluster as a cluster task given to you. You just need to use that. You don't have to create your own task. But there are a few which we have created as our own. So we name it as kind task here. So this generate tag, I have a task which I created here. So it's not a cluster task, but it's a task which I have created. So you can see how it's created in the repository as well. Then we do a sanity check here. There's a script which I call here. Of course, that script was written by a data scientist. Then I build my model. I tag the image for the dev. So all these things which you saw, right, in the pipeline, the CI continuous integration, that's what we are showing here. Then finally, we update the customized repo for dev. Once it's done, there is a new model which kicks in, right? So the ArgoCD will go and roll this out. So here we roll it out using OC rollout command. Then we update the prod, and then the ArgoCD comes in. So this is about pipeline, and then we move into ArgoCD. So let's say I have my, let me show you the console again. I have my deployment, right? So this is the one which I am managing through ArgoCD, this particular application. So I go here and let's say I have, I am scaling up, right, to whatever I want to. I don't care about the resources. Just one fine day I thought I want to blow out the cluster, so I kind of like keep updating it and pushing it to the limits. Now what happens is that the ArgoCD will actually detect that there is a, in the object detection REST, there is a change, right? And there are multiple pods which are coming up now. They're like, as per the replica which I have set here. But ArgoCD says no, it should not be the case, right? Because as per my knowledge and the GitHub repository which I am monitoring, you should only have one replica there. But you're having more than one replica in terms of your pods, you have increased, right, through your OpenShift cluster. So when you do a sync here, so let me show you the difference here. So very cool, nice UI, you get the diff here. It's a compact diff. So here, on the right side, it says that this is what I should have. On the left side, you see what is there in the current state. So ArgoCD will always try to have your right side current desired state mapped to your current state. So when I do a sync here, okay, right. Sync here. Right, so here now I go to my diff, there is no diff, right? And if I go to my, so again I'm moving back to one pod, right, as part of the replica. So this is the beauty of ArgoCD. It will constantly keep monitoring and updating so that the admins can sleep well at night, right? So that's the advantage of ArgoCD for you. Okay. Right, and yeah, in fact, I can delete the whole application. The ArgoCD will be able to build the whole application for me. So if someone thinks of deleting it, the ArgoCD is always there to monitor it for you.
Hello, I have
Yeah,
one
hi.
question. So I see Argo CD. Is it like a console, another console which we can use apart from OpenShift?
Ah, okay, right. Good point. So what you do when you go to your OpenShift console here, right? You get your OpenShift cluster manager, you get your cluster ArgoCD. This is the ArgoCD link you get from your cluster itself. So I have an operator installed here called ArgoCD. This is called, we call it OpenShift GitOps basically in Red Hat, right? And then for Tekton we call it OpenShift Pipelines. So this is my GitOps, and then I will basically have a route to that in my routes here. Right, so that route is pointing to my ArgoCD basically, this link. So you can get the same link here from this section as well. Same thing is there for Red Hat OpenShift Data Science. I kind of like click this guy and it will point me to and get me. So there are other things you can explore as well here in the data science as well. So there are so many partners we have with whom we are partnered here. So you get OpenVINO, there is Intel One API, IBM Watson, Anaconda, then Pachydam, Selden is there, Starburst Galaxy. We are coming up with a use case on Starburst Galaxy as well.
Okay, one more question. So what's the scope of Argo CD? Let's say I have my own namespace and one of my team members has his own namespace. So if I'm using my Argo CD, can I interfere with his project or
no, you cannot. ArgoCD, you need to actually get an access to that particular project. Otherwise, ArgoCD will not be able to do anything. And
So,
ArgoCD works across clusters as well, by the way.
okay. So how do we manage this access? Is it like a
Yeah,
service
you create
account or
service
something?
accounts. You create
Okay.
service account in there, and then you map it back to your ArgoCD.
Yeah, so I just had a question. So let's say in the model that you're building, if you wanted to integrate multiple APIs into it, no matter what they are, how would that sort of work into the whole deployment process? So if you were having
So you need to architect your application that way. Like if you have multiple APIs you're talking
Yeah.
about, right? But is it a single code like you just run and everything runs in the same interface? You have different interface, right? For different API will have different interface access points,
Yeah.
right? So you need to individually run it and then execute that.
Okay, so the pipeline would not account for all the separate interfaces that you have.
In pipeline, you can configure that you basically go and run everything in parallel as well.
Okay.
So
What if you wanted to integrate all your APIs in the same file or the same interface along with your model itself? Like if you have a neural network model and you want to integrate all the APIs along with it to have it in the same file of same
yeah,
program.
you can do that.
One last question maybe.
Yeah.
Yeah, this is also available for kind of a developer version, right? Like you can play around it. Playground is available for this.
So I can't hear you. Can you be louder? Time's up.
Hello, can you hear me?
Yeah.
Yeah. Okay, right, like we can access it for free, right? Like developer access is there for this.
For what?
For all these MLOps to play around.
Developer access, you go to console.redhat.com, there is a minimal thing which you can do there for everything, I think. So yeah, you should be able to. But yeah. The other thing is all this automation which I have done, right? Okay, all this thing is available on, just last thing I wanted to show that, and then I'm I think done. That's called Agnostic D. Just check whether you guys have access to that. So this Agnostic D has, what we have is all the workloads which we run on OpenShift, right? A lot of them have been automated here. So you can use just Ansible playbook. Everyone heard of Ansible, right? How many of you know Ansible, like, or worked on Ansible? Okay, few of you. So it's an automation tool basically, right? So you can actually create. So these are all playbooks available for you to go and deploy your specific workloads, whatever you want. on the OpenShift platform. So this is all open sourced. Okay, I think that's it. And if there are any further questions, I'll be available here till the evening. So feel free to walk to me and ask any questions you may have. Yeah. Thank you for your time.